Right, so now officially, hello everyone. My name is Bea Pessler and I'd like to wish you all a very well and a very warm welcome from all our Meet and Code partners, which is Haus des Stiftens, TechSoup Europe, SAP, and of course, the German Federal Ministry of Interior. Welcome to today's online seminar, Code Your Own Smart City with Snap. I'll say another few words, but before I want to at least briefly welcome our expert today. Lukas, it's so nice to have you here. Welcome.
Thank you very much. Glad I can be here.
I'll say a couple of words to you later on, but first of all, for everyone who might not know Meet and Code yet, let me just briefly introduce the program. So Meet and Code was launched in 2017 to assist nonprofit organizations in providing digital skills education to young people all over Europe. And until today, Meet and Code has reached more than 175,000 young people across 35 European countries. What a number, right? What we do is we offer micro grants of 500 euros to local nonprofit organizations to host the digital skills workshops they deliver. And I'm quite sure many of you are recipients or beneficiaries of those grants already. And for those of you who are not yet, I have good news because you can apply right now and my colleague will just put the link for the application in the chat soon. So if you're not beneficiary yet, go ahead and apply. What's the purpose of these Meet and Code online seminars? The online seminars series is an extension of the Meet and Code commitment to help nonprofits become more innovative and more creative in their important daily work. They are made to provide you with learnings and insights from great SAP expert speakers and coaches. And this is all around the topic of IT and coding, of course, since it's Meet and Code. Okay, but now enough of all the theory, let's get practical. We are more than happy to have Lukas Ackermann with us today. Lukas is a working student in the SAP Next Gen team, and he is also a computer science, geography, and economics teacher in Vienna, in Austria. So as far as I know, he enjoys creating new formats and testing different learning methods to connect the younger generation of today with future aspects of a world that is constantly changing. And he will address this topic today by exploring a playful approach using the block programming language Snap to build a smart city district that thematizes these challenges in a fun, serious game way. And I can tell you, I've just seen a little bit of it so far, and it looks all like colorful and playful. I'm very curious how it's going to be. So this is done by linking the interdisciplinary knowledge of computer science and geography while discussing how to present smart cities and sustainable development goals, short SDGs, in an innovative and exciting manner for young people. Okay, but now I have talked enough, that's for sure, and I'm more than happy to hand over to you, Lukas. Thank you so much for taking the time, and the floor is yours.
Yeah, thank you very much for having me. So the expectations are high. I hope I can fulfill them. And I'm trying to share my screen right now, and hopefully it's going to work. So I need to present the PowerPoint. So and I can double check if, yeah, it works. That's fine. So don't wonder, I've tried out the program or prototype I've designed on my MacBook, but it wasn't able to to run it fluently. That's why I use another computer, and that's why I'm looking always to my right. So today's topic is about coding our own smart city with Snap. Originally, I had an idea and a lot of prototypes, and somehow I've got a final product. So it might not be the thing I had in mind when, saying I'm going to do this workshop, but I think it still will be fine. So I was introduced, maybe some words additional to that. I used to be a tax auditor in Austria for 5 years. Then I started to find my passion in education, worked in edutech companies and landed at SAP and in a public school. And I think that's basically all I can add to already that what Bea said. So I won't need to waste your time onto my person, because that's not so interesting as the smart cities. I've got an agenda prepared for you, so I would like to give myself like a, how do you say, a few things that we should know to better understand the topic I'm going to provide to you. So I would like to talk about the methodological background of game-based learning, serious games, and stuff like that. Then I want to talk about why I've chosen the SDG 11, which is sustainable cities, and why it's combining a lot of other SDGs at the same time. Then, and this is optional, so I'm going to ask you when it's time, I'll give you a short introduction to Snap overall, so it's just to understand what's happening, and then we're going to jump into the prototype I've provided for you. And after that, when we watch that, but feel free anytime during the webinar, ask questions, but after that we'll have a Q&A session and feedback as well, if you want to give feedback, of course. And yeah, a short disclaimer, the Snap doesn't support very untalented person in drawings, so all these paintings are mouse self-painted and they might look disturbing, so you can see yeah, some graphics are really yeah, you need a lot of creativity to know what's going on. But I'll describe it anyway. And oh, wrong button, here we are. Yeah, then game-based learning. So why it's cool and why do you like it to use in the classroom, and why I designed a lot of other formats apart from SAP in Austria, for example, the youth hackathon, so where children or students used to design games and make it like a competition, who has the best game. Why do you like it so much? It's because it makes a ton of fun. You might know the term with other terms like educational or serious game, and what it basically means is we're just using games in an educational context and we'll have serious intentions. So we want to learn somebody something. So it's not just playing around and, I don't know, shoot people. That's not the intention of game-based learning. That might be a good, you can definitely change that to a game-based learning approach, but it's not like at the base. That does not mean with the zero intention that we cannot use conventional entertainment games as shooters as example for that. So you can use shooters if you, for example, want to talk about violence, or does shooting make you an emigrant or something like that. That's very negative right now. That's why I'm giving you a positive example. So for example, if you know the city simulation building game SimCity, they provide, especially for schools and educational purposes, different challenges, and the pollution challenge would be a great example that is super awesome to use in classrooms as well, and follows a more professional approach I'm going to present to you today. So mine is more simple, I guess. Yeah, we love to play, and gamification is basically everywhere. And that's the cool thing about it, because gamification is everywhere. Actually, we have to talk about games in the classroom, in schools, because it gives us the possibility to talk about what makes us addictive. Why do we spend money on games with smartphones? Why do we spend money at our PlayStations, at our Xbox, on our PC? And we need to also have a reflective mindset on games as well, and not just put it down to, yeah, they're fun, so we have to have fun, and that's why we play them. And if we talk about that in school, that's the best place, because you learn, you have fun, and you have the free room to reflect others, but also yourself. And yeah, the cool thing about when you play a game, you get immediate action and a reaction. So the game reacts to what you're doing. For example, let's take the city simulation example. When you build a housing, you get reaction because people are moving into your city. And if you don't provide enough energy, you get a reaction because the people are going to, for example, riot or so. And that's cool things because you learn by playing. And that's what I at least have experienced. And it's, yeah, as I said, just fun. And the cool thing about interdisciplinary games, so for example, the SimCity game, you can do that as well in geography or economics and stuff like that. Wherever you want to talk about cities, you have the same approach as you have in computer science, which is the trial and error approach. You start to do something, you get an error, you get a loss, and you try again. And so you trial and error, and this is you start to empathize with this approach and you start to feel comfortable with trial and error. And what it normally does, that's not always true, but when you play a game, you're able to play it in your own pace. So we have this self-paced learning approach, and often the times there is a problem-based approach as well. So you have a problem, there is a challenge, you want to win the game, you want to solve the problem, and you're like intrinsic motivated. And a good example of again, the wrong button. A good example of a serious game I like to use a lot in classrooms is this game. It's called Get Bad News. Your goal is to be the super villain. You're trying to be the best fake news maker in town. And the nice thing about that, it was developed by scientists basically, and they wanted to know if people are going to learn something from this negative approach. And I've spotlighted their statement from their extract, and I would like to read it, and I'm going to do it. So they found out that people's ability to spot and resist misinformation improves after gameplay, irrespective of education, age, political ideology, and cognitive style. So they found out that they can reach basically every person with this game because it makes fun and it's very sarcastic. So if you understand at least like 1% sarcasm, you're going to understand what's the intention of the game. So I can highly recommend that. Again, wrong button. SDGs, you probably know them, but just for the just for mentioning it as well, we have 7 SDG goals. We want to, the United Nations are trying to make our planet a better place to live, and they formulated 17 goals. And yeah, I think they are nice to integrate in classrooms because they give you an easy approach that is also in the living world of the future generations. So they are going to be confronted with that much more than probably we are. I mean, I'm not that old, but you know what I mean. There are those who change the world and bring new ideas. So why did I choose the SDG 11? Simple thing, I really find it exciting. I love to live in the city. I love to live in Vienna. I studied geography, and a big part of is the human geography. So you should try to think about how is a human reacting to its space with spatial differences and stuff like that. But of course, that's not the scientific answer. I think those stats are speaking for themselves. By 2050, 2/3 of all people on the planet will live or are going to live in urban areas. At least that's the future they say, or they prognosticated. I don't know if that's the correct word in English. Sorry for that. The fun thing about is those cities we are living in, they're only covering 3% of our world's surface, but at the same time, are producing 60 to 80% of the energy we use. They are consuming the 60 to 80% of the energy we use, and they account for 75% of the carbon emissions at the same time. So 3% are basically, guilty for all the bad things, so to say. And the thing is, because of this rapid growth, we are facing a lot other challenges than just no housing, slums and stuff like that. There are problems with water, with sewage, public health and stuff like that. And at the same time, cities are providing economic growth. Like 60% of the global GDP come from cities, and so we have a discrepancy between the bad and the good things, so to say. And that all being said, we can tackle many SDGs by just focusing or starting in our own environment, which is probably a city or near to a city. Let's say it like this for now. And that's why I thought it would be a nice topic to talk about at Meet and Code. Good. I don't want to waste that much time either, so I'm going to follow Bea's advice. I'm going to stop the recording. Not the recording, sorry. I'm going to stop the chat screen and change it. Where is it? There it is. And I'm going to change to Snap. So maybe now the question, do you guys know Snap, the block-based programming language? Or is it completely new to you? In the meanwhile, I'm going to post a link to you guys so you can follow along. All right, so I guess that's a no. So I'm going to introduce you to Snap. So it's a block-based programming language. It's used for, okay, you know Scratch, Leslie, that's basically just the same. So we have block categories, and within these categories, we have blocks that we could use. By drag and dropping these blocks into our working environment, which is right here, we can code. And that's basically it. We can start creating our own blocks, our own scripts. And by clicking them, you see live on the stage that our objects, which are right below the stage, are doing something. For now, I'm ordering this object to move 10 steps every time I click. And it's basically the principle. We have a stage, we can draw something, so we can get creative as well. So I can draw, I don't know, a beach or so. And it's actually quite fast. And the approach of designing an own game, that's the thing I like about using Snap, because when you start creating your own game, you're also reflecting what do you like at games and what do you want to implement in your own game, and you start experiencing games on a meta level. That's at least what I'm saying. I don't know if that's a scientific approach, but it's mine. Good. I'm going to close this because I want to show you the city. And here we are. So I've coded a lot. So you can see I've got a few scripts. I got a few objects right here below my stage. And by pressing this green flag, we are going to start. And the first thing I like is to individualize projects. So I can, for example, the game asked me, what's my name? And I'm going to answer that it's Lukas. And it also asked me how do I want to call the city. And for now, I'm going to call it Vienna because I'm not creative at all. And I thought to myself, oh, that's maybe a good approach. You could actually play along with me. I just need to share it. But again, open. Okay, I'm not logged in. That's not good. I'm going to continue talking and hopefully get my password right. So the good thing about the tutorial is you get to know the controls, you get to know how the play style and stuff like that. And I basically did it just so you can play along with me because I thought it's going to be fun. So I'm sharing that. I'm going to, and with the sharing, I get a link. And now I need to use WhatsApp. Sorry, we are ready in 30 seconds, I promise. But you can use the link even when I'm not going to finish everything. So here is the link. I hope it's going to work. Do you still see? Yeah, you still see the game. All right. So the tutorial asked me says I can use the button D to move right. I can use the button W to go up, S to move down, and A to move left. And now we achieved our first, we solved our first problem. I can make it bigger. And there is a button appearing. And with that button, the tutorial says I can activate the button by pressing space. I'm going to do that. And now we are in our city. And it should not look like that because I had a totally other idea in mind, but it is what it is. I wasn't able to to code my first idea, so I made a simpler approach. We can navigate around the city, so we have our own apartment where we can go to with the same controls we just experienced. We have the park we can visit, and you see I've provided some challenges, some mini games, so to say, for topics I thought they would be exciting. And the main thing I focused on, or maybe start with something fancy and look at the code as well. So in our apartment, you know it, by smart living, we can save a lot of energy, we can save a lot of time, we can have very fancy innovations in our own flat or apartment. And I thought I'm going to implement one fancy thing in the apartment, which is a smart fridge. So you can see by here at the bottom, I have objects that are basically all in our apartment, which is the fridge. And I'm going to open it again with space. And now we're opening our fridge. And where do I need to click? Yeah, here I think it's good. In our fridge, we have items. And by clicking them, our smart fridge knows when they are put away, I add them to the shopping list. So you saw when I click on them, let's look at the apple. When the apple is clicked, when I am clicked, and I am the apple right now because I clicked on the apple, then the apple will be added to the shopping list. And I can, I don't know, eat the fish and the taco because I'm hungry, and then I'm going to close the fridge. And again, I've eaten all those things and they are away from my fridge. But with people, we are people we used to we used to follow behaviors we know. So when you go shopping or you think about your typical grocery shopping shopping cart, then we used to buy basically every time the same things because we like to eat, I don't know, spaghetti, we like to eat, maybe you eat vegan and you just buy a lot of vegetables, or you love fish, so you're going to buy a lot of fish, and you just buy all the time the same stuff. So why not integrate it into our smart city concept, and by clicking on the shopping list, which is right next to the entrance, it reminds me, hey, you need to buy a red apple, you need to buy a fish, and you need to buy tacos because you love these things. And at the same time, it asks me if I want to buy these items at the local market. You know, you could buy it at the normal supermarket as well, but I just wanted it to make more sustainable than it is. And I can say yes if I want to, or I can say no if I want to buy them myself, and the shopping list just keeps up to date until I delete these items. Or I can decide to, okay, because that was a thing in Vienna, at least I've experienced it a lot at friends and family, that you can deliver your grocery shopping cart basically to your home, to your apartment. And that's what we want to do. We say, okay, if I have the possibility, and I know that's regional, I know these products come from near the town, and I support my city, I support the environment, the local economy, yeah, just please deliver that to my home. So I press yes, and now I have those items back in my fridge. I mean, it would not work like that, because some parts are just human, but I just could not code it that you just I don't know, unpack your shopping cart into the fridge. But you get the idea. So let's look at another easy example, so I can show you also the coding side of it, and then we're going to jump into more sophisticated, more topic-related approaches. So for the part, also anytime, because I think right now I've skipped a few parts because I'm quite nervous. If I'm too fast or anything, or you have questions, please feel free to type anything in the chat whenever you want. So you should not be afraid or anything at all. So at the park, I thought, okay, what could be a cool sustainability thing at the parks? And I thought about myself, okay, and I'm a photographer, I'm a passionate photographer, and every photographer loves to photograph the Milky Way. Unfortunately, if you live in a city, you can't photograph the Milky Way, because the night sky is just light polluted, and you can see it's just too much light, too much artificial light in the city. So an approach could be, a very smart approach could be by implementing sensors on our street city light. So this should be a street city light, right? And a smart approach would be that when you come closer to a light, or come closer to a specific area, the lights go on and they dim the light by themselves. So let's look at the code. I have provided 2 light beams to the street. So let's move a little bit there. So you can see we have a light beam on the left, light here, and we have a light beam at the right. And the code is super simple, but so effective, and it just shows you and also your students how easy basically it is also in reality, maybe not technical, but from the coding perspective, how easy it could be by implementing sensors to our street lights to have a smart street light. So what it does, it says, okay, when I receive Smart City Park, that's just our beginning statement. So Smart City Park is broadcasted to all the objects when we click on the button, our smart light. So that's just our starting event. Then we say, okay, just exist. So existing in Snap means show up, and set it to a size. For example, I can completely delete it by using this block right here, and the light is gone. So that's just the graphical effect. So we want it to really show up. And then we have a loop. So a loop is one of the fundamental things we need to have in code, apart from many others. But you use loops very, very often. And then we say, okay, dear light beam, please set your brightness and make it, how do you say, I need to look that up, sorry. Make it dependent on the distance to the character I'm playing. So when the character is far away, we can try that out again. Okay, now it's not working because the script is not running. And the character is far away, the brightness is going to decrease. And when the character is coming nearer, the brightness is going to be more and more, and until it's super bright, or the most bright it can get. All right, so we have the concept, we have a sensing block, we have the blue category sensing. which is sensing the distance to the playing avatar. We invert that because it's just a crazy number. You just, yeah, that's a technical issue. That's just how it is. I know, not a good explanation, but it is so. And we add that by 30 because otherwise it would just be too dark. So that's also something I can show you, that it's not so bright. I don't know. And it gets, yeah, I don't think it's so much likely to get on when you're super close to the light. It would not make sense. So it should start a little bit earlier. That's why I have the plus 30. So I used operators to make the graphical effect more realistic. And then I provided so you cannot enter or exit the level without reading, because I want my students also to learn something. So here I provided some light pollution facts that I've researched on, and maybe you're interested in that. But yeah, we just have so light pollution is not only affecting us humans with our hormones, our fitness and stuff like that. It's especially affecting nocturnal nightlife and nocturnal pollinators with moths and bats. And they play a crucial part in our ecosystem, also in the city, especially in the city when you have a lot of plants that require moths. And the thing we don't care actually about is the artificial light is increasing by around 6% per year. So it's getting basically worse and worse. So we're not, that's a topic sometimes that, unseen basically. Yeah, we have 4 different kinds of light pollution. I'm going to skip that because we want to talk more about the coding aspect. And yeah, that's also a fun fact. More than 80% of humanity experience of light polluted night skies, and 99% of Europeans and Americans. And that's, I think, a nice fun fact to know when you talk about friends. That's also something you can just say, and it's fun. All right. Now we're going to look a little bit more at the coding side. So with the heat challenges, heat is obviously a big problem in cities. You maybe heard the news from Canada, where they had 50 degrees Celsius in Toronto, which is super hot. And I think in Vienna, it's super hot with sometimes up to 40, very rarely, but up to 40. But 50, I could not imagine that. So that's for me, Sahara Desert, something like that. Yeah. So I formulated a challenge, and now I have to look at which variant. So this is the challenges, basically. I formulated them, and we have super many costumes around that. So these are just saying what is going to happen. These are telling our students what are you going to do. And that's why there are so many scripts. But in fact, let's go through one. In fact, it's not so complicated. When we receive the starting statement, and we receive that when we activate the button, then we tell our object, go to a specific location, set your size to 100%, same procedure as before, then show up, switch to a costume, which is basically the sentence I provided, and then waits until I do something. And for now, I've declared a statement, so I'm forcing the code to wait until I press the button B. And when I press the button B, wait a little bit, because otherwise the computer would be so fast it would just scroll through all the costumes. So that's just obligatory, so it works. I wait a little bit and change the costume, and do that so as long as until you reach the costume number 4. So I have 4 statements provided, and we can try that. I press B once, and here is the challenge. So cities are affected by something what we call the urban heat islands. And that's because cities or urban areas are often made out of materials like concrete, like steel, like asphalt, everything that is basically retaining heat, and on the other side, preventing water circulation. So when there is no water, it's hotter. Yeah, that's just the thing. And the result is that temperature in inner cities, for example, where there's a lot of not so much green or anything else that like reflecting the heat or absorbing the heat, we have up to 7 degrees Celsius warmer temperatures. So this is the challenge. This is the background where we now have a playful approach. But there is always hope, and that's where the player comes in. Science has found cool and quite innovative ways, but at the same time also simple approaches how we could tackle these challenges with the urban heat islands, so we can prevent our city to overheat. And step one is just plant more trees. And now it's saying me I should do something. So I've tried to visualize in this game how the urban heat island effect works. So we have a sealed area in our city, which is basically soil that is not usable anymore because we just put a street onto the soil, and heat is coming from the top and reaching our sealed area. The thing is, whenever the heat touches, so let's look at the script, when the heat touches the sealed area, it's getting faster. So the heat will be faster and faster, and our city temperature is rising. What can I do? I can collect trees. So that's what I did here. So I collected my first tree, and I'm going to collect my second tree. Now I collected 2 trees, and the green area shows up. And here we can see when the heat touches, I mean, that's super fast because I talked so much. Normally it wouldn't be that fast. But when the heat touches the green area, plants absorb the heat, they use water, we have soil, we have a thriving ecosystem. It cools down the area, and it cools down the environment around it. So you can see our temperatures are rising, but they're also decreasing. And by planting more and more trees and by creating more and more green areas, we can just tackle the urban heat island effect. And that's a cool thing because you can see with just, 60% coverage of our park here, we reached our starting temperature of 25%. And the game stops when there is only trees anymore. So now there is the stop statement, right? So here we have our informations that the students found out, and then we can also have a look at the code. So the temperature difference between an urban space and the surrounding non-urban space is called urban heat island effect. That's what I basically talked about. And what does help against it is the vegetation evapotranspiration. So the water circulation within the ecosystem, basically. And scientists have found out that this process has great potential to reduce not just urban temperatures, but also global temperatures. And that's basically now connecting to the opening statement from the beginning. So we found out that 3% are responsible for like 75% of the greenhouse gas emissions. So information and information. But let's have a look at the code. What happened in the game? So with our starting area, starting statement, we had 4 objects activated. First, we had our sealed area, which is just a gray area. We don't need that actually. So all it does is when the game is started, we set the size to 100% and we show up. Then we have the heat, of course, that would be the next thing. And here it starts to get a little bit more complicated. I'm going to split up the code a little bit so we can do it step by step. So first, I want to do it for a whole duration of the game. So I'm going to need a loop that says, okay, keep doing that until the challenge is solved or the problem is solved. So keep doing it, But what should it do? We didn't declare it. So first things first, we want it to spawn at the top. And you can see that's now the speed of the computer. It spawns only at the top. Not good enough. We want to do something until something else is happening. So we say we're forcing our heat to do something until it either touches the sealed area. So we have the sealed area, the gray object, or until it touches the green area, which would represent the parks you just saw before, or until it touches my player. So that was my basic idea of the player can also do something to prevent the urban heat island effect. That's why it's implemented. But yeah, it was just one of my first ideas. And then we say, what shall we do? So what do you want me to repeat? Because now I'm just, again, I'm still spawning and I'm doing something until, but I don't know what. And there we have it. We change the Y position by a specific value. And the value, this is a variable, we declare that at the beginning. So we set our heat speed to -2. So we change our value so long until we touch either the sealed area, the green area, or the avatar we play. And now I can declare all the other statements. What should happen when I touch the sealed area? So please, when you touch the sealed area, get faster. So because we're moving down, we change our Y value. That's a coordinate system. We change our Y value by a minus value. And we also increase our city temperature because we want to show the city is getting hotter and hotter when heat is touching sealed area and the heat is absorbed and given back to the environment. Then we want to declare our next statement. And now we're saying, and here is something interesting, and that's where the connectivity of objects and the code and all the other things we need at programming language comes to life, basically. When we touch the green area, we want to reduce the speed. So we're reducing the heat that is coming because, yes, we just want to show that the effect is getting less and less when there's cool air around the hot air. And then we say, okay, when you do that, go back to the top. So now I think we can try it. Okay, we need to first hide this. So if we have now our script, nothing is happening because none of the statements are valid. So we also need to show this one. Let's start this again. So now it repeats to decrease the Y value until it touches the seed area or the playing character. And then it starts again right here at the top to go all through the process again. And we can also visualize this statement. Okay, it takes too long. Okay, we cannot visualize it, but normally you have the possibility in Snap to go through the code step by step by clicking on this icon. But yeah, let's continue. And I don't have much time left. Sorry. And then we can declare other statements. So I've created basically a few errors or bugs I experienced. So these are just bug solving programs. So I've experienced, for example, that the heat got a plus value, so it was moving upwards and not downwards. That should not happen. And I achieved that my city got so cold that we could not live there anymore. So there would not be a heat island effect, but a heat frozen effect, a frozen heat effect. I don't know. You know what I mean. So that would just not make sense. So these are just the statements we need to cover everything. And yeah, what I wanted to say, when the hot air is touching the sealed area, it's broadcasting a message to all the objects. So it's broadcasting cool air to the object cool air. And now we can have a look at the object cool air. And there we have it. What happens when I receive this message? I receive the message cool air. And when I receive the message, I create a clone of myself wait a few seconds, because otherwise we would have the same problem again. They would just spawn infinite objects because the computer is too fast for us to recognize. And then we get another statement because a clone is created. So what should the object do when it's starting as a clone? First, we want to show it up. So please show yourself. Go to the green area. So wherever is the green area, go there. So there's your starting point. And then repeat until you reached the top of the stage. So if I have this right here, you can always use the sensors. So you see the Y position right now from our heat is at 165. So we're forcing our cool air to repeat going up until it reaches a value that is higher than 170. And then we change the city temperature. So we're decreasing the city temperature because cool air is cooling the city down, and hot air is increasing our city temperature. It's just the logic I was following. All right, that was a lot and very fast. And I think it would be better for now if I stop for a moment and give you the opportunity to ask questions or give feedback, maybe ask specific things I can show you and not just show you my thoughts. Yeah. So I see the questions. Scratch is very good. So maybe I'm going to show you that. Yeah, it has. It's not so the designing feature in Snap. Let's create a new object for that. So there's a new object. It always starts at such an error. And the thing with Snap is that you don't have that much creative ideas. So you have all different kind of geometrical figures, and you also have the possibility to create vector shapes. But I would say Scratch is a little bit more advanced in that. What Scratch does not have is something, at least I don't know about that, and I work with Scratch quite a lot, is the things that you could use text code in Snap, and you could use lists and work with lists and stuff like that. So that's the thing I've used for the smart fridge. So you can start with the same simple approaches in Snap as you would do in Scratch, but you have the possibility to get into more complex topics and experience them as well. All right. Did I answer your question? The reshape tool, sorry, I missed that. So let's have a look again. It's again not so super advanced. You have a possibility to shrink it down, and you have the possibility to make it bigger. But you see it's getting a little bit pixie. Let's try it with a vector, then it should be stable. Okay, that's not working. Yeah, so as I said, fix that too. Yeah, let's look at a program where it's a little bit more easier. Maybe I can. I'm just programming something. So let's say we have this tool right here. Then we say do something like we mentioned before. Repeat until you touch the edge and go down and then go back up. So this is basically the same movement I just described to you. So it does that. And you see it's super fast, and you have the possibility to slow it down for a custom head block. what? I'm going to share it as well. New project. Yes. So let's do it. Again. Touch the edge and change one monster. So there you see it. Basically shows you what's happening. So right now we're in the loop of the loop. Yeah, of course, you're totally right. That's one of the main issues you're facing at the beginning when you start with something. So you can see now we've reached the edge, and you can even slow it more down, so it's even faster. And now we're in the loop within the loop, and you can show them, okay, we're doing this loop so long until you touch the edge, because that's what we declared that it should do. And once it touches the edge, that's now the case, it's going back up. So that's a cool feature about Snap, and it really helps you, especially in the beginning, when you experience the coding language itself. That helps you to just follow the sequence. All right. Any more question? I switch back to the smart city. So I've tried to implement a lot of mini games. Maybe that was a little bit wrong approach to just inspire you. And yeah, it's now online because I shared it with you. So again, with the link up, I've shared before. Can I copy? No, I can't copy. I cannot copy the chat, but if you just scroll up a little bit, you see the code, the link, which is referring to this project, and you can go there step by step because it's a lot I've coded, and you also have the informations and make just a sequence out of it. So one approach. Yeah, exactly. Leslie, that would be the approach, but I thought maybe I should start a little bit more advanced to get you inspired, because I don't know, yeah, if it was too easy, if I would just code it from scratch. Exactly. Good.
Hey, Lukas, I'll just help you out with the with the questions, because you're doing it all by yourself now. I'll just also check on the chat, but if there's anything else you want to show us, we still have a couple of minutes left. And also, if you guys have more questions, please feel free, because Lukas will be with us a couple of more minutes. So yeah, you're more than welcome to ask more questions, although we have had a couple already.
Yeah, I've also provided, because I'm not just talking anything, that's just my opinion, I've also provided the sources I've read for this workshop. So you have the scientific articles on the left, you have the web articles on the right. So maybe I can share this presentation with you as well. If it's somehow possible, feel free to use it. Those are quite interesting, but some are German, sorry. Those are quite interesting articles and approaches referring to game-based learning and smart cities in general. And what I just mentioned before, maybe this last sentence from my side, because I'm talking super fast and a lot, sorry for that, but there will be a recording. You could start in the classroom. That's my approach. We all should design one smart city thing, and it could be in your own apartment, it could be on the streets, it could be in the school, and you just focus on this one challenge, and that's basically enough, because you get a super broad collection. If 2 or 3 people are working on one challenge, you get, in a classroom in Vienna, you get 10 solutions, and that these solutions are super creative and they're super great. And all what I've coded are basically ideas from students that I've basically copied and made them a little bit more fluent and with no bugs and stuff like that. But all I've shown you today are ideas from students, and they coded them themselves. That's what I didn't mention before. Yeah, yeah, that's the most impressive part, actually. So I'm just a copycat. I didn't have the source from them because I didn't know if, because of data protection, to mention them. But yeah, all the credits to the students.
Wow, yes, that's actually really very impressive. Thank you for sharing. And also there's another comment of one of our users. She says it was very helpful. I got lost last week in Unicode, but that was very good and helpful. I'm looking for a programming bridge from Scratch to Python, and this looks promising. We have very young coders as well as older coders, and they like the visual side of it. Thank you for sharing. We still have a couple of, oh no, we actually don't have a couple of more minutes,
Yeah.
but still, I just checked the time, but still, yeah, if you have more questions, it's another minute left. So if you feel, if you want to know anything else, but I think we really got a very deep impression into Snap. Thank you so much, Lukas, for taking taking us on this journey. For me, it was very new. I didn't know much about it, and I've learned a lot in the last 60 minutes. So thank you. And I'm sure our participants did also. So thank you for taking the time.
Thank you very much for having the patience to listen to my words. Yeah, thank you.
Yeah, and also, of course, thanks to our partners who support Meet and Code, and thanks to you, our audience, our Meet and Code community, for asking questions and taking the time this afternoon to be with us today. And we hope that you'll be with us again for the next online seminar. Please just check our website, check social media channels, and we'd love to see you again and discuss and hear from you. So once again, thank you so much. And we hope to see you again soon. Have a beautiful afternoon and goodbye.
Bye-bye. Thank you.
Bye, Lukas.